everyone, I hope you all are doing well. This side Priya Bhatia. And in this specific video, we are discussing another interesting concept with respect to log transformations. Till so far in our entire course of machine learning, we have seen a lot many methods which is basically used to handle outliers. I hope you all remember that, right? For example, let me give you a brief idea. We have talked about empirical formula. We have talked about z-score. We have talked about IQR, interquartile range, right? In today's video, our focus is that, let's say if we will be having specifically skewed data, right? And let's suppose that data itself is really important and we don't want to delete it. We want to handle it in an appropriate manner. So log transformations plays a very important role in that scenario. What are those? How basically it will be able to convert any skewed data to a normal distribution? What's the maths behind that? Today we will focus on that part. This is one of the very widely asked interview question as well. And many people in the company have also used this kind of a technique to convert their data from skewed data, specifically skewed data, to a normal form. So let's get started and we'll try to understand the internal maths behind that with its core implementation. So let's get started. So now let's apply the log transformations and let's see basically how it will be able to handle the outliers. Specifically for the skewed data, right? To handle the outliers, we have seen many methods in our entire machine learning course. If I just want to remind you, few of the methods are like z-score method. We have talked about empirical formula, right? We have talked about IQR, interquartile range, in a lot more detail. So what this log transformations is all about and why I'm saying that it is specifically applicable for a skewed data, let's try to deep dive into that part as well. If let's say you will be having a data set which is like this form, means inclined towards right side. This is something which we usually say it as a skewed data. This is one of the most important thing. So when we are talking about unsymmetric data set, we have right skewed or left skewed. The simple literal meaning is that, if the tail is inclined towards right side, that is something which we're calling it as a right skewed data. And if it is vice versa, means the tail is inclined towards left side, that is where we are calling that as a left skewed data, right? Now, at any point of time, whenever we will be having this kind of a data set where the skewness is towards right, maybe, for example, you can say that there are very few instances in our records which belongs to those patient data which is having a very high BP or very high BMI, right? That's a simple example which I'm giving, right? So in that specific case, they definitely belongs to this outliers wala part, right? So how basically we can handle that? Specifically in healthcare domain, why I have taken this example? Because whenever we are talking about healthcare domain, one thing which you always observe that the data set is very, very important. Even the outliers available in that specific data makes a lot of difference and contains a lot many important information. So we cannot directly get rid of them, right? For example, few days back, I was just working with one health stock data set. And in that specific data, the glucose and BMI of the patients contains many outliers, means they are very rightly skewed, means their values are very, very high. And they somehow indicates a clear-cut information about, having the stock value as one. So in that specific scenarios, it's not a good idea to remove those outliers. Now, what we can do, we can already seen that, yes, we can do outlier imputation as well via median because it's a skewed one. We can handle it via maybe IQR or any other stuff that we have discussed so far. But the better idea could be, because I don't want to delete the outliers. I just want to handle it in an appropriate manner. So the better idea is to apply log transformations. Now, what is happening when I'm saying log transformations, it is nothing but log based in whatever be the data points that you have. So if you will apply this specific thing to all the records that you have, so what will happen is you will observe that your data will become normal distribution. This is how basically your data looks like. normally distributed. Now, why is that so? When I'm saying normally distributed, it simply indicates that, almost 50% of data lies towards left side and almost 50% towards right side. So almost 50% towards left side and 50% towards right side. So this is something which we are calling it as a log transformation, where we are trying to basically convert or transform the data which is available in the right skewed form to a normal form, to a normal distribution. Now, you can ask me that, Priya, how is that possible? Can you show us some mathematical intuition behind the same, so that instead of cramming these stuffs, we will be able to understand these concepts more logically? So yes, we do have. Just try to understand. For example, if let's say, I will say I have some big number, maybe a record which contains data point value as 1000. And if let's say I'm applying a base as 10. So what do you think? What is the value you will be able to get? Definitely, I hope as per the logarithmic properties you all know, we can write this value as 10 ki power 3, and this is nothing but is equals to 3. So what is happening is, whenever you will be having a very, you can say, bigger data point, somehow you will be able to observe that it is giving us a smaller value. Somehow shrinkage is happening to a bigger data point that we will be having, right? That's the main thing. That's the main intuition that you have to understand. The bigger the value, the more the shrinkage we will be having. But what if we will be having a smaller value? As this kind of understanding is not applicable specifically for those data points which are left skewed or having a smaller data points. Why? Because if you will do log base 10 for any small data point, let's say 0.1, now try to understand what is the value you will be able to get. It will be 1 by 10 or 10 ki power minus 1. So the answer will become here minus 1. How I'm concluding this? Again, it's very easy to understand if you are aware about the logarithmic properties. Log base 10, and you can write it as 10 ki power minus 1. Again, power can come ahead, so this value will become minus 1. So one thing which you will be able to observe, that basically when we will be having a bigger values, it is somehow shrinking. When we will be having a very, very small values, it's somehow giving us a expansion of the values, right? So what is happening is, overall, with the help of this specific results that we are getting, it will be clearly able to handle the outliers pretty well, in such a way that at the end of the day, if let's say you are having outliers available, for example, let's say you will be having a data set which contains outliers. Maybe this is a box plot that you have. This is the middle point. This is where you will be having the values available. And let's suppose you are saying that this is the upper whisker, this is the lower whisker, and I have the outliers available on the upper whisker, let's suppose. So what is happening is, you are doing a complete transformation altogether, log transformation, and you will be able to get a new set of data points, I would say, in which all the records available contains almost, you can say, contains almost, you can say, important information, or the values are between the upper and the lower whisker altogether. So that's the main idea behind this log transformations. Let me try to demonstrate you the same thing with the help of one practical implementation, so that you will be able to get an idea. For example, I will be having some random data available with me, right? I have curated a list of data points that we have. It's random, but if you will try to see this, it's a positively, or you can say right skewed is also positively skewed. So I'll write it as right skewed. So here you can see, if you will run this, and if you will try to curate a plot of this right skewed data, right, once again, you will be able to see one interesting thing. Let it run. So one thing which you will be able to observe, why is that happening? PLT is not defined. Why is that so? Okay, if it is not defined, let me define it here. So import matplotlib dot pyplot as PLT. Now, if I'll just try to showcase you, this is how basically this graph looks like. One thing which you will be able to observe here, that whatever data points you can see as a part of this one or this one or this one, all are the outliers that we have, right? Now what we will do, or what I'll do here is, let's go below. we will try to see the distribution plot also, and you will be able to observe that this distribution is also right skewed, because as you can see here that the tail is towards the right side. Very simple illustration to understand the skewness part, right? Now, once it will be clear, let's move ahead. And another interesting fact which you will be able to see, now we want to convert that to a log transformed way, and we will see again the box plot as well as the distribution plot of the same data set that we have, right? Let's try to see that. So what I have done is, we have a data frame available. We have stored that in our input array. So again, we will be having the same data set. Now, this is our input array that we have, right? And now what we can do is, we will try to apply np.log base 10. So when I'm saying log transformation, by default, the base is 10, as I already told you. And if you will try to see your now output array looks like this number. So every data value, every data point that you have, we have converted that into log base 10 value with the help of this NumPy module that we have. Now, if you will just try to see again the column name right skewed, but now we have output array. I'm not working with the input array, which was the original values that we have. I'm working with the output array. And now if you will just try to see the distribution plot for the same, you will be able to realize that we will be somehow very, very close towards this normal distribution. I hope you are realizing it. Somehow it is closer to the normal distribution that we will be able to achieve here, isn't it? So what happens, and even one more thing which you have observed, which you must have observed here, is that in this case, if you will be able to see that there are no outliers which are available, which was there in the right skew data. Here, those outliers are completely removed. That's the, you can say, advantage of using this log transformations. Please make a note that these kind of transformations are helpful only if you feel that data is limited, or you are dealing with a healthcare specific data which contains a lot many information, and maybe you want to store that information, you want to retain that information, but on the best side you want a normal distribution as well. So the better idea could be where you can try to convert your right skew data to the log normalization, and you will be able to get this kind of a result. Now, if let's say you want to revert back the original values that you have, so what you will do, it's just simple maths that you have to apply. If you will just try to take a square of 10 to the power of, that number, which is the output array that you have, right? So if wants to revert back, you have to take log base 10 values to the original value. For interpretation purpose, what you have to do is just raise 10 to the power, right? 10 to the power of that output array that we will be having. So what we are trying to do here is, how basically we will be able to revert back towards the original data that we have. So what we supposed to do, if you know the internal intuition behind logarithmic, it's very easy to understand that why we are doing 10 keep power of that output that we will be able to have, right? So here you can see the same answer from where we started our journey. We will be able to revert back, right? So this is the overall idea behind log transformations. What does that impact? In interviews also, interviewer can ask from you that, what is the impact of log transformations, and why basically it is happening that, we will be able to handle the outliers pretty well. What's the impact internally it is doing? I hope that this answers your question. With this, let's end today's video. I'll see you all very soon in the upcoming videos. Bye-bye everyone, and see ya.